Here's one that Charlotte's going to use in the upcoming ACA OLX 2 workshop. I just thought I'd give it a little go and see what new tools we have in OLX 2 that could be used in the disorder modeling that we're going to find. Let's solve it. Solve shellXT tends to be my default program for just about everything nowadays, and P21 upon N is looking good, and it should hopefully pop up. There we are. Okay, everything seems to be in place. These sulfurs are there. Everything is fine. So this structure is solved. And let's refine it. Let's just make sure we're using shellXL today. So hit refine. And that looks all very good. And we can already see there is maybe some Q peaks around here. Those balls are bigger than those ones here. So this is also meaning there's probably something going on in terms of disorder on this one here. So let's first of all make this one here honest. Okay, the heavy thing is out of the way. It's bromine. It's very, very heavy. And there we go. We can see what's going on here. So I click on this and type unique, and that gives me just this, and we can see how there's an alternative position of this and this and this and this. So one of the new tools in OLX 2 is the following. I hide the Q peaks, double click on the whole thing, and it's mode fit -S, because I want to not just fit it but split it. Same, and redo. Okay, so Control Q to switch those peaks on again, and now with just the left mouse I can rotate this around and see whether I can find a position where these atoms overlay those Q peaks. So I'm aiming for this one here. As you can maybe see, it's not so simple to do. It's not so hard. It takes a bit of practice to twiddle this, but it's not so bad. So these two are overlapping. These ones look quite good. So everything looks quite good. So you can see this doesn't really overlay. There's no reason why it should. Obviously the arms can wave about, but that's good enough for the moment. Just hit escape a few times and Control R for refining this. This is something I don't quite understand why it ununiques it. So we just have to live with this. I click on this and type unique and refine again. And if, yep, there we go. So this looks quite good. The occupancies are clearly linked. So we're looking at 69% here and 30% here. Refine this a few more times until it really settles. It's settling nicely. Refine again. And I would recommend probably to just add the hydrogens to this thing now. Add and refine again. And this ununiqued it again. Right, unique. Okay. Anis, let's make it anisotropic and refine it again. And it's behaving rather well. So what's in here? So there's a couple of things here. So this become NPD. Now that's not totally surprising. These two atoms are really on top of each other. So what we're going to do, put a del U 0.001 and quite a strong del U here. I think that's justified to do that. So for the moment we're looking at 5.47% R factor. So this del U is making it looking nice, and we're looking at a lower R factor. So we actually found a real minimum here. Or something else has moved, but it certainly hasn't pushed it up. Now we ununique it, so we click on this and we just click on nothing and type unique. That's how we get everything back. So all of these are still isotropic. Type anis and add and refine this as we go. Okay, 3.28% is looking good. Control R and Control R again. Everything settles nicely. There is a little problem here, and I'm not quite sure what to do about this, because that one here doesn't look like it's a carbon, but I'm not really sure. I think this is how it was in the original. Let's just see what happens if you make this. Well, first of all, let's look at the map and see what the map says. The map also agrees this should be heavier, so let's make it a nitrogen. Now, I don't know whether this makes much chemical sense now, and it's certainly healthier. So maybe this is actually a nitrogen. There's something else going on, because this is now also elongated here. So it could be a carbon. So this is really for the chemistry to sort out here. So the map looks better, though. I'd be saying that probably we're looking at something of this nature here. What's wobbling? So yep, it's one of those UQs here. So it's just the formula. Make sure we've got the formula right. click on this again. So this is still wobbling a bit, but we haven't got the weighting scheme on yet. So if we switch that on as well, hopefully a bit more shift and it's going to settle down nicely. Come on, yes, it's coming down. Okay, so here we go. I think this is a nice way of showing how you can model this disorder. One thing that we can do now, obviously when I first split it, it put in some restraints because that's what we asked for. So these SADIs are in place. Now maybe these were only needed to actually move it in the right position. So let's delete the whole thing. I'd probably keep the regus in there, but if we delete this whole lot here, and just see what happens, whether these restraints were only really needed to guide it or whether they made a difference. And you see nothing happens at all. So these restraints did nothing anymore, but they were obviously needed to push the whole model into the direction that it actually ends up with. And I think this is a nice demo on how these new splitting tools in OLX 2 are going to be very useful. Thank you for using OLX 2.